So let's look here at number 10. So here it says, Philip throws a basketball up in the air and through a hoop. Because the ball is acted on by the force of gravity, the ball will. So we're going to figure out what exactly is going to happen to this basketball from the moment that it leaves Philip's hands until the point that it actually goes all the way through the hoop. So let's make an illustration here, a diagram, so we can try to figure out exactly what it is that's going to happen. So let's just say, this is my hoop. I know it doesn't look that great, but that's okay. So there's my hoop. We're going to say that Philip is right over here. And so he throws the basketball in the air. So that's your basketball. So we're going to figure out exactly what's going to happen. Now this ball, as you know from basketball, will take a curved path. So it'll go higher and higher and higher. And eventually, what's going to start to happen to the ball? It's going higher, and eventually it has to start coming back down, right? And it actually goes through the hoop. So when it leaves Philip's hands, we know that it has a great amount of potential energy because he just threw it up in the air. But as you go higher, it starts to kind of slow down. It kind of loses part of its momentum. And part of the reason for that is because, one, you only threw with so much energy, but in addition, the force of gravity is starting to overpower the force of this basketball from when it left your hands. So as it goes higher up this way, it starts to lose momentum and it starts to slow down. So as soon as gravity right here, really takes full control and the ball starts to come down, it's going to change its direction. Because it was going upward, now it's going to be going downward. And so as it goes through the hoop, as gravity really takes full force, it starts to speed up quite a bit until it finally hits the ground right there. So we're going to figure out exactly which of these answer choices matches what happens when Philip throws the basketball through the air and it goes through the hoop. So letter F says that the ball will slow down, change direction, and then speed up until it hits the ground. So far that looks like it pretty much matches exactly what our diagram has. But we still need to look at the other answer choices just to make sure. Letter G says it's going to speed up, change direction, and then slow down. Now, gravity doesn't cause things to slow down. Now, I know what some of you say. Some of you say, well, but with gravity, since gravity is the same on all objects, shouldn't they all fall the same rate? It shouldn't speed up. Yeah, if we were in a vacuum with no air resistance or any other forces around us, yeah, that would definitely happen. But we do have a few other things that also act on this. So because that letter G doesn't make sense, it definitely won't slow down at the end. Letter H, it's going to travel at the same speed and same direction until it hits the ground. So if I throw it up, the ground is under me. It's lower than that. So if it keeps going in the same direction, that means it's just going to keep going higher and higher and higher. It's just going to keep going until it finally floats out of the earth and into outer space. That obviously doesn't make sense because we know gravity causes it to come back down. So it's not just going to keep floating off. And letter J, it changes direction and travels at the same speed until it hits the ground. So we throw it up in the air, it doesn't change direction immediately. It has to, again, lose some of its momentum and some of its force when gravity finally takes over that force and then changes the direction of it. So because that F is the only one that would make sense in this specific case. Let's go and look at the next one. Number 11. Most of the ocean floor is a type of rock called basalt. At the edge of continents, this basalt erodes and becomes small particles. Over time, the particles are compressed and form what type of rock? Alright, so if we're actually taking a look at this, we have here at the edge of continents, we have a bunch of particles, alright? So imagine a bunch of pieces like this, right? Because that's what particles are. So when these get compressed, remember, what is the word compress meaning? Because we saw it earlier in another example with a spring. Great job. It means to squeeze, right? It squeezes them together. There's another word that we've used with the rock cycle that kind of not sounds the same as compressed, but it means the same, where you're squeezing things. You're bringing things together. Great job. That other word is to compact it. So in this case, which type of rock is formed when you have all these different particles, which are sometimes known as sediments, and they compact? There's only one. Great job. The answer would be sedimentary. But let's look at igneous. Where do igneous rocks form? What happens in order for an igneous rock to form? Great job. You would need to cool lava or magma. So in this case, nowhere in here are we talking about lava or magma. So in that case, it definitely won't be igneous. For metamorphic, we have, remember the pH that we have there? So that stands for there's a lot of pressure, and there's also heat. So we would have pressure here when they're being compressed, but one, it doesn't tell you anything about heat, and metamorphic, we know that that's underground. Okay, that's under the crust. So in this case, even when it's in the ocean, it's not exactly where it's happening, but even when it's in the ocean, that's still above the crust, right? It's not actually under yet in the mantle where the metamorphic rocks are going to be forming. So in that case, it's not going to be C either. So in this case, our only option that makes sense with this would be letter B, the sedimentary rock. Let's look at the next. Number 12. 4 balls made of different materials are placed on a tabletop 2 meters from the floor. So you have your table here. You have ball A made of styrofoam at 5 grams, ball B made of rubber at 18 grams, ball C made of plastic but it's hollow, meaning there's nothing in the inside, it's just the outer part is plastic, it's a shell, 2 grams, and then finally ball D, solid plastic, 21 grams. The question asks, which ball has the greatest amount of potential energy? Alright, so normally when we talk about potential energy, we talk about height. So the higher it is, the more potential energy it has. But in this case, by reading the first sentence here in our question, they all have the exact same height of 2 meters. So how are we going to be able to figure out which one of these balls has the greatest amount of potential energy? So for this, we look at our formula for potential energy. Potential energy equals mass times gravity times height. So let's start with ball A as an example. So if I'm using ball A, my mass is going to be 5 grams times gravity, which is 9.8 meters per second squared, times the height, which is 2 meters. So what does that give us? Exactly, the potential energy in this case right here would be 98. Then if we take a look at ball B as an example, we have a mass of 18 grams times our gravity of 9.8 meters per second squared times our height of 2 meters. So when you multiply those numbers out, what does that give us? Great, it's 352.8. So what is the only thing changing from ball A to ball B? Great, the only thing changing is the mass, right? So the more mass you have, the more potential energy, or the less mass you have, the more potential energy? Great job. The more mass you have, the more potential energy you have. So in this case, the ball that has the greatest mass would also have the greatest amount of potential energy. So let's write that down. More mass equals more potential energy. So which one here from ball A, B, C, and D has the most mass? Great job. Ball D, solid plastic with 21 grams, has the most mass here. Therefore, it also has the most potential energy. So ball D would be our correct answer. So if you're still having some trouble with with this concept, if you go back and look at the video I posted on YouTube a few months ago about potential and kinetic energy, I give more examples there about how mass influences the amount of potential energy. So go ahead and take a look back at those to help you. Let's go and look at the next one.